For a product with many variants, it is more efficient to manage the range as a single variable structure, with a configurator to manage the variability data. However, when you configure this variable structure to derive a distinct variant with no variability, it is not represented as a static structure in the system. This poses a problem when you need a physical representation of the variant for any downstream processes, such as when sending it for manufacturing. To remedy this, you can capture and identify each distinct variant as a solution variant. Let's try to understand solution variants using a product, Crosscard, that has two variants, Base and Deluxe. Both these variants are managed within a single variable structure. To derive the base variant, you apply a valid configuration. This is based on the variant rules already set in the configurator for Crosscard. As per the variant rules, the i4 engine and blue seats must be used in the base variant, while a V8 engine and green seats must be used in the deluxe variant. Based on these rules, the Crosscard is configured, and the base variant and the deluxe variant are derived accordingly. In these distinct base and deluxe variants, the Crosscard, engine assembly, and seat assembly are not uniquely identified even though they contain different parts. Therefore, to identify and represent them statically, you create their solution variants. By default, a solution variant is always created at the topmost level for a specific variant. For example, when you select Crosscard, engine assembly, and seat assembly to create their solution variants for the base variant, 3 separate solution variants are created. Each solution variant has a unique identifier. They are identified as Crosscard base, i4 engine assembly, and blue seat assembly. Similarly, 3 solution variants can be created for the deluxe variant, namely, Crosscard Deluxe, V8 engine assembly, and green seat assembly. The source structure, Crosscard, is maintained as a separate entity and is linked to each solution variant. It can continue to evolve. Now, consider that you update the source structure, Crosscard, to add transmission, a new part that has variability. As you updated Crosscard, its solution variant must also be updated. You can also choose to create a solution variant for transmission. This time, when you create a solution variant of Crosscard base, the solution variants that were already created are reused. Additionally, a new solution variant for transmission manual, is created based on the valid variant configuration of Crosscard base. As solution variants are also created at the assembly level, the variable parts can be reused in other products. For example, consider that you want to reuse this engine assembly in another product, buggy. As per the variant rules defined in the configurator, an i4 engine is used in the standard variant of buggy. When you create a solution variant of the engine assembly for the standard variant, instead of creating a new solution variant, the one that was already created for Crosscard base is reused. To conclude, the distinct solution variants are uniquely identified and represented in the system. Teamcenter ensures this by comparing the content with a list of existing solution variants before creating a new one. These solution variants, generated at the product or assembly level, can be used in downstream processes.